These are the notes for Algebra 2, Section 8.4. This is the second part of 2 for Section 8.4. The first part dealt with simplifying rational expressions. Now we're going to multiply and divide rational expressions. And what we're going to see is that multiplying and dividing is really just an extension of simplifying. Let's start with multiplying. If we're going to multiply rational expressions, right, a, b, c, and d, as a fraction down here, you can see a over b times c over d. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. That means that the same rules that we have been using all our lives to multiply fractions, whether we remember them or not, are the same if we're multiplying rational expressions. Right? We multiply the numerators and we multiply the denominators. Right? We multiply straight across. Right? There's no flipping around, there's no moving, there's no voodoo involved here. We multiply straight across. A times C over B times D. Once we've got A times C over B times D, just like with simplifying, we want to see if there's anything that can cancel out. Fairly straightforward process. Like I said, it is really closely related to the simplifying process that we were doing in part 1 of section 8.4. Let's look at an example here. Example 1, we have 2x squared plus 4x divided by x squared minus 4x minus 12 times x squared minus 9x plus 18 over 2x. Now, much like when we were simplifying rational expressions, our first job will be to factor numerators and denominators. And this is where things can take a little while. It's probably the longest part of the whole process because we have to factor all of these. Right? And if we have 4 different things that need to be factored, that could take a while. In this case, we can factor out 2x from 2x squared plus 4x. Right? Factor out a greatest common factor. Gives us 2x times x plus 2 on top. On the bottom, factoring this denominator, this is a trinomial. It begins with x squared, so I'm going to start with my parentheses and my x's. The last number is negative, so one's going to be positive and one's going to be negative. And the factors I'm looking for would be negative 6 and positive 2, because negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. Moving on, I need to factor this guy as well. Now, again, I'm going to start with my parentheses and my x's. This last number is positive and the middle number is negative, so both of these guys have to be negative. Now, the factors of 18 that add up to 9 would be 6 and 3. So that's my factored terms. On the bottom here, I just have 2x. 2x is a single term. I really can't factor a single term, so I'm just going to leave it that way. That is my first step, and that is the longest step. Everything else is going to go much quicker than this first step. Second step, moving right along, is to multiply the numerator and the denominator. Right? We multiply straight across. And with what we're doing, that basically amounts to just putting the stuff next to each other. Multiplying all this stuff together gives me 2x times x plus 2 times x minus 6 times x minus 3. So you can see we literally just line everything up when we multiply. There's not much to it. Now, let's see over here. We have a 2x on the bottom. We're going to put that in front. We have x plus 2, and we have x minus 6. Once we've done that, our last step is to divide out common factors and write in simplified form. Dividing out common factors, of course, the same thing as canceling things out. For instance, we can cancel out the 2 and the x. We can cancel out x plus 2 and x plus 2, x minus 6 and x minus 6. This leaves us with just x minus 3. And that is my answer. Keep in mind that when we cancel everything out from top or bottom, we have a 1 left over. So this is x minus 3 over 1, which is x minus 3. Let's look at another example here. First things first, we want to factor. So that's going to be our first step. So let's factor. We've got 2x squared minus 10x. That we can factor out a 2x there. So we get 2x times x minus 5. On the bottom, x squared minus 25. Remember, this is x squared minus 0x minus 25. Okay? X squared minus 0x minus 25. Which means that we're trying to get the factors of negative 25 that add up to 0, which would be 5 and 5. Positive 5 and negative 5. Add together to get 0, multiply to get you negative 25. Over here we cannot factor x plus 3, so we're just going to leave it that way. And we cannot factor 2x squared. Our next step here would be to multiply. So that's what we're going to do next. And again, multiplying, it's just combining everything all together in one big pile. So 2x times x minus 5 times x plus 3. Over, I'm going to move 2x squared to the front. 2x squared times x plus 5 times x minus 5. And my last step is to cancel. So that's what I'm going to do last. And you can see the 2's cancel out. One of the x's on the bottom, it's x squared, so one of the x's on the bottom and the x on the top cancel out. X minus 5 and x minus 5 cancel out, leaving us with x plus 3 on top and x plus 5 on bottom, but we're multiplying that x plus 5 times x. I'm going to rewrite that so it looks a little bit nicer. You need to keep in mind that this x is still here. That x has stuck around, right? So it needs to be there. We don't need to distribute it. We just need to leave it the way it is. But we do have to write it in as part of our answer. We cannot cancel it out with anything. Okay, let's look at division. We've seen multiplication. That's how we do. We factor, then we multiply, then we cancel. Division is very similar, but we're going to add one step to it. Just one step, not even a big step. To divide one rational expression by another, we want to multiply the first expression by the reciprocal of the second. And of course, reciprocal, we know, means to flip the fraction. Now, our example here, we have a over b divided by c over d becomes a over b times d over c. You see, we flip these guys around. And of course, when we do that, we get a over d, or ad, over bc. So the only difference between multiplying and dividing is that the first thing we have to do is flip that fraction. Flip the fraction. Got to do that. Let's see how this works. We start by multiplying by the reciprocal. Here we have 3 over x plus 7 divided by 8x squared minus 8x over x squared plus 6x minus 7. We want to multiply by the reciprocal. The first term stays the same, 3 over x plus 7. But now, instead of dividing, right, division becomes multiplication, and we take the reciprocal of this guy. So, x squared plus 6x minus 7 goes on top. 8x squared minus 8x goes on bottom. From this point, it's basically exactly the same as multiplying. There's almost no difference whatsoever. We'll start by factoring. We're going to factor everything we can. We can't factor 3. We can't factor x plus 7. Right? Those go without saying. We can factor x squared plus 6x minus 7. The last term is negative, so we have 1 plus and 1 minus. Make that a little bit bigger for us here. Right, I want to give myself plenty of room to write. We have x and x. We have 1 plus and 1 minus because of negative 7. And it looks like the numbers we want would be positive 7 and negative 1. Would add up to 6x. On the bottom, this is a binomial, so we can only factor out the greatest common factor, which is 8x. When we factor 8x out, we get x minus 1. 8x squared, factor out 8x gives you x. 8x, factor out 8x gives you 1. Now, we're going to skip a step here. I don't typically like skipping steps, but we're going to do it anyway. We can go ahead and do our canceling out. Now, as you remember from our multiplying, we combined everything together with multiplication, then we canceled. We're not going to worry about the combining part. We should understand that on top we have 3 x plus 7, x minus 1. On the bottom we have x plus 7, 8x, and x minus 1. And we can just go straight to canceling out. So that's what we're going to do. X minus 1 and x minus 1 cancel out. X plus 7 and x plus 7 cancel out, leaving us with 3 over 8x. And that is our solution.